Good, good. All right, so I hope everybody's starting working on the project. And today we actually are going to be moving to our third part of this course. So we are going to be starting our probabilistic, statistical, and the machine learning part of this 1690. Okay, so this first lecture in this part is to introduce you to thinking probabilistically. So at the start of this lecture, I want to have you watch a video. If you probably have seen this before, but I'd like you to take a look at this. This is basically how SpaceX is recovering the fairing. That is, see, yeah. So this is a video of SpaceX recovering the fairing, and I'd like you to take a look at the video and discuss a little bit of why doing this at least seems to be a lot more difficult than recovering the first stage. So let's take a look at the video. So this is the fairing coming down on the parachute, and this is the boat that's supposed to catch it. And here we go. Oops. Of course, this is actually a successful one later on. But can somebody tell me why recovering a fairing like this, the procedure, is more difficult? At least seems to be. Yeah, I'd like you to just have an open discussion. Unmute yourself if you need to.
You can
Or
control
chatting
the
the chat.
descent.
Sorry?
You can control the descent of the powered stage as it falls back, but you can't control the fairing. It's just pushed around by the wind.
Yeah, it's pushed around by the wind. You don't have as much control, right? Okay, anybody else? Any other factors?
It's also released much higher up than the stage, right?
Yeah, it's released much higher up. That's right. Yeah, but if you focus on the catching part of the mission, particularly the failure we have just seen, seems to be not as much related to the height at which it is released. But you are right; it is actually released much higher.
Is the boat is also moving, so you're trying to catch a moving target with a moving target?
Yeah, you are trying to catch a moving target with a moving target. The boat is actually moving, but the boat moving actually is to the benefit because the boat actually moves to catch the ferry, right? If the boat stays there, it's actually much harder because the parachute basically drops to wherever it wants. So the boat actually tries to catch the parachute actively, right? Okay, I think the first idea actually carries a lot of weight. So here we actually have some control, right? The boat actually steers itself, and the parachute also have some steering capabilities. But the control here actually is not as effective as the rocket booster compared to what you cannot control, which is the waves and the wind. When a rocket is landing, it has actually pretty tremendous control, right? And having tremendous control, if you studied the control before, you know this fascinating thing called a negative feedback. Okay, so if you have a lot of control authority, and that enables you to have a lot of negative feedback, and that basically removes a lot of fluctuations, a lot of uncertainties in the input. I mean, the input being wind or the waves or whatever. So even though you have a lot of uncertainty in the environment, if you can have a lot of negative feedback, it basically removes, it basically diminishes the effect of these uncertain factors. In this case, not so much, right? We can steer the parachute, we can move the boat, but the amount of control we have, the authority we have, is more or less comparable on the same order of magnitude as the uncertain environmental factors, like the wind and the wave, right? I mean, if you watch this again, you actually see a lot of you might actually see a lot of a wind kind of buffeting the fairing around, especially when it is close to landing, when it is actually getting close to the sea, interacting with the so-called atmospheric boundary layer. So there is a lot of environmental factors, right? You see like things, the wind really playing a big factor here. So what we are discussing in the probabilistic part of this lecture is actually how do you take into consideration of the uncertainties that we may not be able to predict and actually affects the output of a engineered system like what we have here. Okay, so basically in the previous part of this class, we are solving ordinary differential equations and partial differential equations. But we have been thinking about the differential equation being deterministic, which means we assume we know everything about the system. We also assume the initial condition being deterministic, which means we know exactly how the system starts. We assumed we know all the parameters of the system exactly, right? Which we don't in most cases. So there is a lot of things we cannot control and we cannot predict or we cannot know precisely. And these are the things that we usually model in a probabilistic way. Okay, so that's kind of the introduction to the motivation of why we want to look at things probabilistically.